All right, students, let's continue our 2.2 where we are graphing the quadratic equations, and we are trying to find out the different transformations that are happening. So far we figured out how it stretches or shrinks, or how it goes left and right and up and down. Okay, so let's do next one, and it says graph each equation without using technology, so no calculator. Okay, so let's do that. Now this plus 3 is telling me that my original x squared graph, the y equals x squared, it is moving up 3 times, okay? And then this negative is telling me that it's upside down, okay? So if I was graphing a regular x squared y equals, or f of x equals x squared, then this would be my vertex. But because I have this plus 3, then I will be moving my vertex 3 up. So 1, 2, 3, this will be my vertex. And then this time, because it's upside down, so my regular one, I go 1 up and I graph it here. But so the regular x squared graph, I would be going 1 up and graphing it. But because this is negative x squared, I will be going downwards 1. So this will be my x squared, negative x squared plus 3 graph. Now if it was a regular parabola, then I would be going 1, 2, 3, 3 up, and same on the other side. But because it is negative x squared plus 3, I will be going, because of the negative, I will be going downwards 3 times. So 1, 2, 3. So right here, and then 1, 2, 3 right here. Okay. And this is how I would be graphing it. Let's plug in now. This is asking us to plug in the values. So if I put 0, so 0 plus 3, so f of 0 will give me 3, okay, which is this point here, 0 and 3. So this is our vertex, so 0 and 3. Then if I do negative 1, then negative, and then negative 1, and square of that plus 3 will give me 2. So I will have 2 here and 2 here, which are these 2 points. If I have negative 2, then square of that will be 4, but negative. So negative 1 plus 3 will give you, negative 4 plus 3 will give you negative 1, which these 2 points that we figured out. So negative 1, negative 1, and if I keep going for negative 3, I'll be getting negative 9 plus 3 will give me negative 6. So negative 6 for this, negative 6 for this. And if it is 4, then I calculate and it will be negative 13. Okay. Now for here, the next one we go 5 up, this one will be going 5 down. So 1, 2, 3, 4, 5. So right here, and for this one right here. And if I draw it, this is how my parabola will look like, and this is a upside down parabola. Okay, let's do next one. And so again, this one I can tell that this takeaway 5 is moving it up. I'm so sorry. This negative 5 is moving it down. So sorry. Okay, so takeaway 5 is moving it down, and then this plus 2, because it's inside the parentheses, it is taking it to the left. Okay, so my original for y equals x squared is at 0, 0, but I'm moving 2 to the left, so here, and then 5 down. So 1, 2, 3, 4, 5. This will be my vertex for this one. Now after that, there is no number here, so it's not shrinking, it's not expanding. It's just after that moving like how x squared graph moves. So we will be going 1 up for the next points, okay, and then 3 up, 1, 2, 1, 2, 3, 3 up. So this one 1, 2, 3, 3 up, and then the next point will be 5 up. So 1, 2, 3, 4, 5. So right here, and then on the other side also right here, and then you connect it, and this is how your parabola looks. Okay, and then so the vertex for this one is -2 and -5. For this one, the vertex was 0 and 3, which is right here, which we can see here also. It is repeating before and after. So for this one, we have -2 and -5. When I go -3, so then I will be doing -3 plus 2, square of that, take away 5, that is -1, and square, take away 5, which is 1 take away 5, which is -4. So this is -4. When this is -1, then it also -4. And if we calculate the rest of the values, when this is 0, then it will be -1. When it is 1, then it's 4. All I am doing in my head is I'm plugging in the values for x and calculating, just like I showed you one of them. And then they all repeat in the other direction. So -1, 4, and 11. This is -4, -5, and -6. Okay. So this is our table, and we can verify our points. So we have -4s, these both are -4s, then -1 are these 2 points, then 4 are these 2 points, and it goes upwards. Okay. All right, let's do next one. Okay, and then again it is saying without using technology. So I can tell that this takeaway 2, moving it down, okay, our vertex is going down, and then this takeaway 1 is, the vertex is moving 1 to the right, okay, and then this 3 is shrinking my graph. Okay, so I will show you how we will draw it. So then instead of our vertex as 0, 0, we are moving 1 to the right and 2 down. So it's right here. This is the point. Now this is how we were going 1 up earlier, okay, to get these 2 points. This time we will going 3 times of that. So we will be going 3 up. So 1, 2, 3, this will be your point, and on the other side also 1, 2, 3, this will be your point. Now initially if it is y equals x squared function, then in that case first we go 1 up, then you go 3 up, but this time we will be going 3 times 3, which is 9. So you will be going 9 up. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is your point right here, and then the same one right here, and this is how you can see it is shrinking. Okay, and we can also tell because this is A and A is greater than 1, so it will shrink, and that's what we decided last time, and that's what we are writing right now. Okay, let's graph it. So when this is, so our vertex for this one will be 1 and -2. Okay, so this is your 1 and -2, and when this is 0, so let's plug in. So we will do h of 0 will be 3 times 0, take away 1, square of that, take away 2. So this will be 3 times -1 and square of that, which will give you just 3 times 1, take away 2, which is just 1. Okay. So then this is 1 and this is 1, so and this is 2, which we figured out. Now let's do the next one. And when we are, so 3, and then next one will be -1, when we are plugging in -1 and -1, square of that, and then take away 2. So that is 2, -2, which is 4, and then 4 3s are 12. 12 take away 2, which will give you 10. So 10 here and 10 here. Okay. And then when it is -2, then we will have 3 times -2, -1, square of that. So this is -3. -3 times -3 will be 9, and then 9 times 3 is 27. 27 take away 2 will give you 25. So 25 for 4. And let's figure out for -3. So we will do negative, so 3, and then -3, take away 1, square of that, take away 2. This is -4. -4 times -4 will be 16, and then 3 times 16 will be 48, and then 48 take away 2 will be 46. So 46 and 46. Okay. Now let's do next one, and this is just summarizing now what we the work that we did. So let's do that. Okay, so this is our, again, like we told before, this is the standardized equation in vertex form. So this is the parabola equation in vertex form, where this h and k, so these two constants, they are the vertex, and this a is your factor that decides if it shrinks or expands. Okay. So, what point is the vertex of the parabola? So, we just said is h and k, where h is the x coordinate and k is the y coordinate. Now, what is the equation of the line of symmetry? Now, if you remember, we did in 2.1 is that if you are drawing the axis of symmetry, then it always passes through from the vertex. So, they share the x coordinate. So, the equation for the axis of symmetry will also be x equals h. So, that is we are writing again. So, h equals x equals h. Now, what can tell if the parabola opens up or down? If a is positive, then it opens up. And if a is negative, then it opens downwards. Okay. How do you identify dilations? Dilations means the shrinking and stretching. So, we said if a is more than 1, or if a is less than -1, that means its value is not in 0 point something. In all those cases, it will be shrinking, so it shrinks, and it will expand on stretches when a is between 0 and 1. That means a values are something like 0 0.7, 0 0.5, 0 0.2, things like that. When it's 0 point something, in those cases it stretches. Okay. So, the parabola looks like this. For shrinking, it will look narrower. So, something like these. Okay. Then, does it matter in which order the transformations are done? Why or why not? Like, what it is asking is, when you are moving it up or down, does it matter if you are moving it right first and then up or down, or left first then up and down? I would say no, it doesn't matter. Okay. So, this is our 2.2 notes.